Hey guys, today we talked about box plots, and we're just analyzing box plots today. We're just looking and identifying statistical calculations that were on the box plot. Okay, so I'm over here. A box plot is really just a box, and then it's got these, we call them whiskers, or we call them, that extend out to the lower extreme and that extend out to the upper extreme. Now, each part of the box plot is really super important because it tells us something about the data set. So in the middle of the box, there will be a line, and that line represents the median of the set of data, okay? The left end of the box represents the lower quartile. The right end of the box represents the upper quartile. The furthest point that our whisker extends to, that's our minimum or our lower extreme. And the furthest that point that the whisker extends to the right, that's our upper extreme, or that's our maximum. So identifying some box plot statistics. If we're looking at this one right here, this represents some DVD costs. And if I look, the first question says, what is the median? So the median is going to be this line right here in the center, and that is represented by a 20, okay? What is the lower quartile? The lower quartile is the left side of my box. So here's the left side of my box, and we're gonna kind of have to judge a little bit here, but it's close to 15, okay, 15. Now, what is the upper quartile? The upper quartile of my box right here is the right side of the box, okay, and so it's a 26. Now, we can calculate the interquartile range using this box plot because all we're going to calculate is the upper quartile minus the lower quartile. So we would take our 26 minus our 15, and we get that the interquartile range is 11. Then number 5 says, what is the lower extreme? The lower extreme is the furthest line on the whisker. So if we look, it is 7. Okay, what is the upper extreme? The upper extreme is the furthest line on the whisker towards the right. So if we look here, that's a 29. Okay, now we can calculate the range using those two numbers. Our maximum, which is 29, minus our minimum, which was 7, gives us a range of 2. Now, box plot, the reason that we draw our box plots is to represent percentages or percentiles. Okay, now, the quartiles in a box plot break the data into 4 equal sections. We talked about that yesterday when we talked about quartiles. Each section of the box plot represents 25% of the data. Okay, that makes sense, right? 100% of the data divided into 4 sections, 100 divided by 4, would tell us that each one represents 25%. So from the lower extreme to the lower quartile, here is one section, so that's 25% of data. From the lower extreme to the median, here is another section, so it's another 25% of the data. From the median to the upper extreme is another section, so that's another 25%. And then from the upper quartile to the upper extreme, that's another section, so that's another 25%. Now, if we're talking about percentiles, percentiles mean like you did better than this 25% or you did better than 90%. When we're looking at our box plot, this represents the 25th percentile because there's 25% below it, okay? The median represents the 50th percentile because there's 50% below it. The upper quartile represents 75th percentile because there's 1, 2, 3 sections or 75% below it. Then the upper extreme would represent the 100th percentile because all 4 sections or all 100% are below it. Okay, so if we look at our question here, it says Amanda scored a 75 on her statistics quiz. Which of the following is true about Amanda's score? Well, if she scored a 75, she would be right here, okay, which is on our median. So we know that 50% of the class scored below her because there's 2 sections below her. We also know that 50% of the class scored above her, so that means that 50% scored better than her. So our answer would be B. 50% of the students scored below Amanda, while 50% of the students scored above her.